Welcome everyone again. So today we are going to learn how to calculate the relationship between pressure, volume and temperature and the number of moles using the ideal gas law. So what is this ideal gas law? So the ideal gas law combines all gas variables into one equation. So all gas variables we are combining them into one equation. What are these gas variables? Which is pressure, volume, temperature. So a number of moles. So let's go ahead and write the ideal gas law formula. So that's PV is equal to nRT. That's the ideal gas law, where P is equal to pressure, V is equal to volume, N is equal to number of moles, R is equal to it's a gas constant, and T is equal to temperature. So that's the ideal gas law equation. Now, the one thing that you should know, the most important thing that you should know is that gas constant, the most common value for the gas constant is R is equal to 0.0821 liter ATM more inverse K inverse. So that's a gas constant, and we use this when pressure is in ATM and volume is in what? In liters. Also, temperature must always be in Kelvin. Now, having talked of that, let's go ahead and try to solve this example, which is saying find the volume occupied by the 1 mole of gas at 1 ATM and 273 K. We want to find the volume. Now, I said that we are going to combine all this through this same equation, which is PV is equal to nRT. Now, we are given pressure, which is 1 ATM. We have been given temperature, which is 273 K. We have not been given the volume. So let's go ahead and find the volume. So what the first thing that we do is we write the formula first, which is PV is equal to nRT. Then after writing the formula, we make V the subject of the formula. When you make V the subject of the formula, you're going to find that the formula is going to be nRT over P. Now, all we have to do is substitute the values. What is the number of moles? The number of moles there is 1 mole. What about the R? We use the same value, which is 0.0821. What about temperature, which is 273 K, and the pressure, which is 1 atm. So we said that we use the gas constant when pressure is in ATM and temperature is in what? In Kelvin. So we can use the what? This gas constant. So there we go. I've tried replacing, and I didn't want to remove the units. So you are going to see that these units will be cancelling. For example, more and more inverse will cancel, ATM and ATM will cancel, K inverse and K will cancel. At the end, we are just going to have liters, which is volume is in liters. So what's the answer? When you are going to punch that on the calculator, we are going to find that the answer that we are going to find is 22.4 liters, and this confirms the molar volume at standard temperature and pressure, because pressure is 1 atm and also the number of moles is 1, and 273 K is the standard temperature. So that's why we are seeing 22.4 liters. And you are seeing in the previous lesson I talked about this 1 mole of a gas to have what? 22.4 liters. So that's the first example. So let's go ahead and solve example 2. So the second example is telling us a gas occupies 5 liters of 2 atm and 300 K. Calculate the number of moles present. So here we have been given the volume, which is 5 liters, pressure, which is 2 atm, and temperature, which is 300 K. And we can use the gas constant of 0.0821 because of pressure being in atm and volume being in liters. So let's go ahead and write the ideal gas law and make N the subject of the formula. So you see, N is got PV over RT. All we have to do is replace the values there. We have the number of moles and everything. So let's just replace. So when we replace, this is what we are going to have. So mind my handwriting. So this is 300 K. So we are going to see that K inverse and K will cancel. Then also liters here and that liters will cancel. ATM and ATM will cancel. The only thing that we are going to have is the moles, because that's what we are looking for. And we are going to find that the number of moles when we punch this on the calculator is going to be what? 0.406 moles. So these are the number of moles that we are looking for. So ideal gas law, you just need to be playing around with this formula, which is PV is equal to nRT. Whenever you have been given these others, maybe you're asked to find temperature, just replace in the formula. Whenever you have been given the others, you want to find the number of moles, use the same formula, which is PV is equal to nRT. So let's go ahead and solve the last example, which is, is it the last? Which is example 3. So for example 3, we have this example, which is a sample of gas contains 0.5 moles in a 10-liter container at 350 K. Find the pressure. Also here we are going to use the same formula, we just make P the subject of the formula. So when we make P the subject of the formula, that's what we are going to have. Then we just have to replace the values. So what is N? N is 0.5. What about the gas constant? 0.0821. Then temperature is what? Is 350. So that's what we are going to have, and when we punch the calculator, we are going to find that the answer for pressure is 1.44 atm. So that's the answer that we are going to find. So that's all about the ideal gas law, which is PV is equal to nRT. And from the formula, we're going to see that pressure increases when the number of moles increases, and also volume increases when temperature increases, but pressure decreases when volume increases. And this explains gas behavior in a container. So that's all about ideal gas law. So try out the practice problem that are shared on the screen, and thank you for watching, and don't forget to subscribe for more lesson videos.